Okay, so uh, good evening, miss, and to anyone that is watching. My name is Kanan, and this will be video evaluation 3 at the 16th of November 2021. So, in this video evaluation, we will be discussing and solving a sinusoidal question. And throughout this video evaluation, we are given of only one number, but it is given of multiple sub questions towards the number. So, without further ado, we can begin. Now, in the first, or the sinusoidal function that has been given to us, stated that it has a max point at 5, 4 and a minimum point at 11, minus 2. So, I've done the rough graph, or basically a rough sketch of the graph on paper, and as you can see, it's not that pretty, but it is the closest that we can get. And it follows from the 5, 4 down to 11, negative 2. It also asks us to not only draw the graph as a one complete cycle, but to also state the functions, or basically two of the functions that could make up the graph. So, in order for us to graph the sinusoidal graph, or basically just to make the function in general, we require a few value sources: A, K, D, and C. A and K will represent the horizontal and vertical stretch or compression. D and C will be the horizontal and vertical shift. So, with the help of the graph that is presented to you in front of the screens right now, we can tell that A is 3, since the midpoint that we have received is equal to 1. So, the gap between the midpoint to the maximum and minimum is 3. So we can put A as 3. Now, the K, however, is pi over 6. We could get the value of K by simply taking the period from which the starting point of the graph started and to the end point of the graph, or basically the distance between them, and divide it by pi over 2. So, the starting point is at 2, 1, and it ends at 14, 1. The distance between the starting and the end point is 12, and that should be 2 pi over 12, and it will be simplified to pi over 6. Now, we can move on to the vertical and horizontal shift. The horizontal shift will be, or basically D as a horizontal shift will be at 2, since the start of the graph starts at 2, 1, as you can see. And the C will be as the vertical shift at minus 1, since the midpoint is at y equals to 1. Yeah, sorry, I stuttered there for a second. So, we've collected all the values of A, K, D, and C, and now we can simply put them into a sinusoidal function. From the graph, as you can see right here, you could see that this is a sine function. So, the easiest way that we can do is to follow, like so. That means the function of x shall be 3 sin pi over 6 x minus 2 plus 1. To follow this is to be A is to be in front of the sin, the K is to be multiplied by x, and the D inside the bracket, as you can see, and the vertical shift shall be outside of the bracket. This is one of the functions that we need to find. The other one, however, is going to be cos. Now, from the graph that you can see right here, you could tell that there's a sin, but it asks for 2. So what we can do is that we can take where you will think the cosine of a graph will start, and that will be around at 5, 4, the maximum, since cos always starts at the maximum point. So we already know D, and A, K, and C will remain the same. All that's different will be the horizontal shift. So we can have the other function to be as so. That is fx equals to 3 cos pi over 6 times x minus 5 plus 1. We can test this theory by going to Desmos with the link provided on the screen. So, in Desmos, I have already set a few things as it can help us throughout the correction. We can start with the points that will be part of the graph, or basically in which the graph is going to touch later on. That is the starting point, the maximum point, back to the starting point again, the minimum, and back to the starting point. As you can see, this will perform a sinusoidal wave. Now, using the graph that we have created, or basically the function that we created, like so, you can see that the graph passes through each point perfectly. Now, it also passes through all the maximum, minimum, as well as the middle point as well. The middle point will be as y equals to 1, the maximum will be y equals to 4, and the minimum will be y equals to minus 2. And such, our graph or our function is correct. And this concludes the video evaluation tree for the 16th of November 2021. Thank you for listening, and I'm sorry for any mistake that I created along the way.